All right, shall we regroup here and do some logarithmic equations? That's what we should do, some logarithmic equations. Just kind of click on so I can see you and say hello. It's always nice to see you. Yeah, that's pretty good. Okay, so let's get down to it. Logarithmic and exponential equations. We're going to use what we've learned about logarithms to solve some equations. So first we're going to solve some logarithmic equations. I gave you some problems here that you should take a look at. Then we're going to solve some exponential equations using logarithms. Let's just talk about the difference between a logarithmic equation and an exponential equation. So first of all, a logarithm is always going to have the word log in it. So if you see that, you know, it's a logarithm, right? And a logarithmic equation has its variable generally as the argument of a logarithm. So we're going to figure out how to kind of solve those problems for x. An exponential equation means that the exponent is a variable, right? This is important to recognize because they're very different. Because for one thing, logarithmic equations, we know that there's a domain issue with logarithmic equations. The argument of a logarithm has to be greater than 0. But for an exponential equation where the variable is an exponent, the domain is negative infinity to positive infinity. There is no domain restriction. There's no denominator, there's no radical sign, there's no logarithm. It's not defined unless it is. So the domain is negative infinity to positive infinity for an exponential equation. And then we're going to show you how to use a calculator to solve these kind of equations. And that'll help you check your answers when you're doing it algebraically up here. So, a couple things to remember. If I have y equals log base a of x, I can change that into exponential form by taking the base, moving it over to the other side. So this becomes a to the y because a logarithm is an exponent, and that equals x. So going from logarithmic form into exponential form is one way to liberate a variable from the argument of a logarithm. Another way is if I have two logarithms, it's the same base, so I have log base a of m is equal to log base a of n. Well, I don't need the logarithms for that. That means that m is equal to n. So that's another way of getting the argument out of a logarithm. If I have a straight up log of one thing and a straight up log of another thing, and they're both the same base, I can just get rid of the logarithms. It's like saying, if I have log base 5 of 3 is equal to log base 5 of x, well, I mean, it's pretty clear, don't you think, that x is equal to 3? That makes sense? Yeah? Okay. All right. So we're going to use those. So I have log base 3 of 4 is equal to 2 log base 3 of x. So I can see here that I have the same base, but I have this factor in front of this one here. So if I can get it to be log base 3 of 4 is equal to log base 3 of something, then I can just get rid of the log base 3s. Do you understand what I'm saying right here? If I can get rid of this factor of 2, then I'll have log base 3 of 4 is equal to log base 3 of something, and that something will be equal to 4. Well, let's use property number 3 and move this back up here to an exponent. And I say log base 3 of x squared. So we have to get the magic bowl. Magic bowl, magic bowl, magic bowl. Magic bowl, wrong pre-calc class. This is the right pre-calc class. My question is going to be, what is x squared equal to, based on what we've just learned? What is x squared equal to? Alex.
Is it equal? Might be completely wrong. Is it equal to 4?
Well, it might be completely wrong, but it's not completely wrong. It's completely right. Confidence, Alex. No questions. Come on.
The parentheses just threw me off a tiny bit.
Well, the parentheses, I'll put parentheses in now. Now how's that? That better? That's good. Okay, now don't let the parentheses throw you off. Right. So it's telling me that x squared is equal to 4. Because I have the same logarithm on both sides, I can just get rid of them. I am not dividing by log 3. Okay, that's not what I'm doing. I'm just using a property of logarithms that says, I mean, I don't know. To me, this seems pretty straightforward. If I have log base 3 of 4 is equal to log base 3 of x squared, then x squared has to be equal to 4. So I would take the square root of both sides, and I would have x is equal to plus or minus 2. Does that make sense to everybody? Yes? But, and this is where we really should have started the problem. If I have a logarithm, a logarithmic expression, the argument has to be greater than 0. So x has to be greater than 0 in this problem. Which means that my answer is not plus or minus 2. My answer is only x equals positive 2. So I have to find the domain of my logarithms in doing these problems in order to make sure I don't have any extraneous solutions. Let's just take a look at how we might check that problem. So let's do this here. Let's go. Yeah, okay, let's just do this. Okay, so I had functions, miscellaneous, log base 3 of 4. I'm going to say y equals this, y equals that. So I have that line right there. And then my second one, I'm going to say 2 log base 3 of x. So that looks like that. Everybody see what I got here? Yes? So the only place that these two cross is right there where x equals 2. That is my answer. -2, sorry. No solution there. Because the domain of my logarithm is x's have to be positive. Questions? Not yet. We're doing okay. Okay, we're doing okay. Good. All right. Now, okay, we're going to get a little bit tricky on this problem here. And we're going to start by finding the domain of this equation right here. Okay, so I'm going to go to here and I'm going to paste it. Okay. I want to find out what is the domain of this equation. I know that the argument of a logarithm has to be greater than 0. Is everybody okay with what I just said there? Okay, we're going to take a little process here. Okay, so I have two logarithms in this equation. I have this logarithm and I have that logarithm. This one over here says x plus 2 has to be greater than 0. So this one is saying x has to be greater than -2. Is everybody okay with that? Yes. Okay, good. Well, this one over here is a different logarithm. This one here is saying 1 minus x has to be greater than 0. So -x has to be greater than -1. That means x has to be less than +1. I multiply both sides of this by -1. And when you multiply by negative on an inequality, you have to flip the inequality sign. Everybody okay with that? Are you following me? This is important. Okay, great. I'm going to make a number line. We like number lines. 0, 1, 2, 3, 4, -1, -2, -3, -4. Okay. My first logarithm says that x has to be greater than -2. So I would write that, I would put an open circle here at -2 and an arrow going that way. Is everybody okay with how I just graphed that on the number line? We're good with that. This one here says x has to be less than 1. Well, let's take this blue one right here for just a minute. I can satisfy the blue one by saying x equals -3. -3. -3 satisfies the blue one, doesn't it? Yes, but it doesn't satisfy the red one. So if x was equal to -3, this would be impossible. So I can't do that. Similarly, if I said, what about something like +4? Well, that satisfies the red one, but it doesn't satisfy the blue one. If I said x equals +4, this wouldn't work. This would be a negative argument. Can't do that. So the domain of this problem is only where I have both lines. So it goes from -2 to 1. That's where, well, yeah, and not including both of those. That's where I'm crossing both lines. If I can only cross one line, nope, can't do it there. So my domain of this problem is -2 to 1. So let me pause there and make sure everybody understands what I said. Ask me a question. Put it in the chat if you want, whatever. Yeah, Maria, please.
So I get everything, but I was just confused in terms of like the algebra behind how we got one, why we multiplied with a -1 instead of subtracting the 1.
Okay, so good. I see what you're saying. All right, so I had 1 minus x greater than 0, right? I did subtract 1 to start with. And then I got -x greater than -1, but I want to find out what x, not -x. So that's why I multiplied by -1 on both sides so that I could turn this into a positive. You got it? Okay, good. Okay.
And then if you multiply or divide by a negative, you always have to switch the sign, right?
Yeah.
Okay.
Yeah. Multiply or divide by a negative, you got to flip the inequality sign. Okay, so I know my domain is -2 to 1. Let's go back to the problem then. So let's see right here. Make sure we got it right. Yep, -2 to 1. Okay. The second thing I have to do is I want to get the left side here as a single logarithm. I need to get the left side here as a single logarithm. Well, I'm going to go think back at my properties again. Log m times n is equal to log m plus log n. So it looks like this is my m and that's my n. So I have log base 2 of x plus 2 times 1 minus x is equal to 1. Is everybody okay with that? I want to make sure everybody understands that step. Ask me a question. No, we're good with that? Okay. Well, let's FOIL this out. Log base 2. So I have x minus x squared plus 2 minus 2x equals 1. So log base 2 of negative x squared minus x plus 2 is equal to 1. Follow what I just did there. I made it into a quadratic. So I've got it into a single logarithm and I made it into a quadratic, but I still need to liberate my x's from the argument. Well, I'm going to do that by putting this into exponential form. So now I have negative x squared minus x plus 2 is equal to 2 to the 1 power. I took my 2 over here, that's my base. My 1 is the exponent, so I have 2 to the 1 power. So if I want to solve a quadratic, I have to get everything on one side of the quadratic. And since I don't like negative x squareds, I'm going to add x squared, I'm going to add x, and I'm going to subtract 2 from both sides. So I'm going to go minus 2 plus x squared. And now I have 0 on this side. And on the right side, I have simply x squared plus x. Are we okay with that? Okay. I did that because I wanted to, if you want to solve a quadratic, you need to get everything on one side and set it equal to 0. So I have it set it equal to 0. So I think what I'll do is, first of all, I like to write my x's on the left. I get kind of confused when I don't. So I am going to factor out an x, and I have x times x plus 1 equals 0. So I can see I have two solutions. One is x equals 0, and one is x equals -1. Are we okay with that? We're good, okay? But let's check my domain. do both of these answers fit in my domain? My domain goes from -2 to +1. And yeah, both of these numbers are in that domain. So I think that my answer is this right here. I think I have two answers that make this equation true. So let's take a look and see. Let's go to Desmos. Excuse me. So I'll do log base 2 of x plus 2 plus log base 2, come on, log base 2 of, it was 1 minus x. So there's my graph of one of them. That's an interesting looking graph, isn't it? Notice the domain of that graph is from -2 to +1. Can you see that? I've got vertical asymptotes right there at -2 and +1. It's just going to go down and down and down and down forever. Never going to be able to cross those vertical asymptotes. And then my second question was it equals 1. So I'll go y equals 1. And I see that I have an answer right here at -1 and 0. X equals -1 and x equals 0. Questions? Any questions on how I'm graphing it? Everybody's happy? Okay.
Mr. Jenkins, can you go back to the other one? Because I didn't know what it, yeah, in the purple section.
Yes.
I'm kind of confused as to what it says. Like, I don't know, like, is that supposed to be a negative in front of like the x2 and then, or is that plus sign? I don't know. I guess I just can't understand it.
Yes, good. Okay. So do you follow what I have right here? Are you good to this point right here?
Yes.
Okay, so I changed this from logarithmic form into exponential form. So I moved my base 2 over to this side right here. So I got 2 to the first power on that side. Are you good with that?
Yes.
And then that left my argument without the logarithm now, since I changed it to exponential form. So it's -x squared minus x plus 2. Are you good with that?
Yes.
So then what I did was I know that I have to get it equal to 0. And I could have moved this 2 over to this side, but then I have this -x squared. And I don't like solving quadratics when I have a -x squared. So I decided to move these 3 terms over here to the other side. So I subtracted 2, I added x, and I added x squared. Do you follow me right here?
Yes.
Are you sure?
Yeah.
So that's how I ended up with, well, the +2 and the -2 cancel out. So I just ended up with x squared plus x equals 0. Are you good with that, Isabella? I couldn't hear you. Yes? No?
Oh yeah, I am sorry.
You're good with that? Okay, great. And then I just solved for it. So did that answer the question?
Yes, thank you.
Oh, you're very welcome. Everybody else okay with it? Yes? Okay, good. Then let's look at another problem. Hang on a sec. Okay, so let's start by finding the domain of this problem, okay? So let's see if somebody can help me here. Mary Rose, can you help me find the domain of this problem? Let's start with this way. How do I find the domain of this logarithm right here?
It has to be greater than 0.
What has to be greater than 0?
X minus 1.
Okay, so I go x minus 1 greater than 0. So x has to be what?
Greater than 1.
X has to be greater than 1. Is everybody okay with that? Okay. How about the next logarithm? Okay, Isabella A. What's going to be the domain of this logarithm right here? You there, Isabella? Okay, it's all right. Jordan, what's going to be the domain of this logarithm right here, the blue one?
X is greater than -2, or oh, sorry, wrong one. X is greater than 0.
X is greater than 0, and this one here, you got it right. X plus 2 has to be greater than 0, so X has to be greater than -2. So I have 3 domains to satisfy here because I got 3 different logarithms. So I'm going to make a number line. And I'll go 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And my first one, the red one, says X has to be greater than 1. So here's 1, and there's my graph of that one. And then this one says, the blue one, says X has to be greater than 0. So I graph it like that. And then this one here, which I should have made a different color, says X has to be greater than -2. So I go like that. So I'm looking at this and I'm thinking, well, maybe I'd like to use the number -1, and that works fine for the green line, but that's not going to work for the blue line or the red line, is it? And maybe I want to use +1/2, and that works for the green line and the blue line, but that doesn't work for the red line. It has to work for all 3. So anything greater than 1 is going to work for all 3. So my domain here is +1 to infinity. Anything less than +1, not going to work. We okay with that? Yes? Okay, so let's
I
go
have a
back.
question.
Great, go for it.
So for the domain to be, well, I just like, why wouldn't it be to like -2 to infinity?
Mm-hmm. And this is where it gets confusing. So I'm glad you're asking this, right? It's because my domain has to work for all 3 of these logarithm pieces. So if I said my domain was equal to -2 to infinity, that would include like -1, wouldn't it?
Yes.
Right? But if I say x equals -1, then this logarithm is going to be -1 minus 1. This is going to be ln -2, and the argument of a logarithm can't be negative.
Okay.
Same thing over here. If I said my domain was -2 to infinity, -1 is between -2 and infinity, right?
Mm-hmm.
Then this would be ln of -1. That doesn't exist.
Okay, got it. Thank you.
It has to fit all 3 of them. Yeah, thank you. That's a good question. That's what confuses everybody on these questions. Okay, so now let's see if we can make the left side a single logarithm. Well, again, I'm going to use my properties of logarithms, and I have, let's do this one here. So I have, I can make the left side a single logarithm, ln x minus 1 times x equals ln x plus 2. Is everybody okay with what I just did there? Using property number 1 of logarithms. Okay, good. So this is ln x squared minus x equals ln x plus 2. Well, I have a logarithm of the same base. So this is telling me that x squared minus x is equal to x plus 2. Right? It's the same thing if I had ln of 3 equals ln of x. I know that 3 would equal x. Well, I have ln of x squared minus x is equal to ln of x plus 2. So that means x plus 2 has to equal x squared minus x. Is that pretty clear to everybody? Yeah, okay, I'm seeing mostly nods. All right. Well, it looks like I got another quadratic going on here. I want to get everything to one side. So I'll subtract x and I'll subtract 2 from both sides. And I get x squared minus 2x minus 2 is equal to 0. Can I factor that? I don't think that's factorable, is it? That's a bummer. What am I going to do? It's not factorable. If it's not factorable, how am I going to solve it? Yeah, Mia.
Would you use the quadratic formula?
I think that's just what I would use. I would use the quadratic formula. So I'm going to start out with b squared minus 4ac. So b squared minus 4ac. And you remember it's ax squared plus bx plus c. So b squared would be negative 2 squared minus 4 times 1 times negative 2. So this is 4 plus 8, that's 12. So now I'm going to go negative b plus or minus the square root of 12 all over 2a. So that is going to be negative 2 plus or minus the square root of 12 divided by 2. So I have positive 2 plus or minus the square root. I'm going to change this 12 to 4 times 3 over 2. Everybody still with me? Going okay? All right. So I have 2 plus or minus, I can take a 2 out of here. 2 square root of 3 over 2. And so I can have a cancel party because I can invite both terms in my numerator to the cancel party. So I can divide by 2, 2, and 2. So I get 1 plus or minus the square root of 3 as my answer for this. So this goes 1 plus or minus the square root of 3. That is my answer to this. Is everybody okay with that? But we have a problem, because my domain is, my domain is 1 to infinity. My domain is 1 to infinity. So 1 plus the square root of 3, that one's going to work. But 1 minus the square root of 3, that's going to give me a negative number. So that one's not going to work. So I think this is my only answer, 1 plus the square root of 3. Well, I think I need to check it. So let's go to x minus 1, x, and x plus 2. So I go ln x minus 1 plus ln, come on, ln x. That's one side of the equation. And the other side of the equation was ln x plus 2, ln x plus 2. So I can see that they only cross right here at 2.732. They do not cross anywhere else. So if they only cross there at 2.732, well, I'm going to get out my calculator. And view, I'm going to go, what is 1 plus the square root of 3? 2.732. So I've confirmed my answer. Aren't these fun? Many different little pieces. Loads of fun. So there you go. Try a problem. Give it a shot. You can do it. Look back at your notes. Think about it carefully. A lot of stuff we just threw out here. A lot of stuff. And the way you're going to learn this is by doing practice problems. Oh, what a unique idea. All right, so let's see who can help us with this problem. Ariel, are you able to help us with this problem? No mic, so I guess you're not. Okay, well, listen carefully. Alex, can you help us with this problem?
I can try.
Go for it, try it.
Okay, so the first thing I did was I took the 2x plus 3 and made it, greater than 0. I think that's how it's supposed to go. Yeah.
That's
Greater.
good, uh-huh.
And then I got the end result was x is greater than -3/2.
So x has to be greater than -3/2. Great, so you found the domain. That's a good start, excellent.
And I was confused. There's only one domain right now, or
This one, because 3 is greater than 0. There's not, it's not a variable. Yeah, so yes, there's nothing, that one's okay, yes.
okay. And then I put it on a number line, so just did that.
Okay,
And it was right above like negative or like -1.5 around that area.
but it should be exactly right at that area, right?
Yeah, and then I just went right from there.
That's good, okay, good.
And then that's as far as I got because I was considering 3 to be something, but I could try and go farther now if you want.
Well, so yeah, well, to give it, what would you try next?
Well, I would define the domain.
Well, okay, so we did that. Okay, so the
Oh, yeah, we did.
-3/2 to infinity.
And then would you I'm not exactly sure.
Okay, so I'm going to ask you a question here.
Okay.
If I have log base 5 of 3 is equal to log base 5 of x, what's x equal to?
Oh, 3.
Okay, well, I don't have 3 and x here, but I do have 2 log base 5s on either side of this equation. So what's my next step?
That's going to be just putting it as 2x plus 3 is equal to 3.
2x plus 3 is equal to 3, and we'll subtract 3 from both sides, yeah?
Mhm.
Okay, so that gives me 2x is equal to 0, x is equal to 0, and that fits in our domain, doesn't it?
Yes. It does.
So I think our answer is x equals 0. What does everybody else think? That look like our answer? Yes? So what do we do next? Go to the next problem? Is that what we do next? Yes? No! We graph it. We check our answer by graphing it. Gosh, how many times? How many times? Log base 5, 2x plus 3. Let's see here. We graph it. Okay, so I'm going to go log base 5 of 2x plus 3. That's one graph. And then on the other side of the equation is log base 5 of just 3. That's going to be a straight line because it's a constant. Oh, I gotta say y equals. And sure enough, it crosses just at that one spot right there where x equals 0. I got the right answer. Yay, got the right answer. Pretty good? Everybody good with this? Press go to do some more. Let's do another. We'll do one more. Ooh. Yeah, go ahead. Give it a shot. Oh, this one's a little bit tricky. Yeah, give it a shot. Notice though, that I have 2 logarithms here And there is a minus sign there, okay? It is not a plus sign. So I have to use a different property to get it into a single logarithm. So Sydney, can you help with this one? Sydney, are you there? Sydney? Yes. No? Okay. Mia, can you help with this one?
Yes.
So what did you do first?
So what I did first was try to find the domain. So I did x squared minus 9 is greater than 0. So then I like solved that and then got x has to be greater than 3.
Okay, kind of, but go ahead.
And then for the next one, I did the same thing and did x plus 3 has to be greater than 0 and got x has to be greater than -3. And then I drew the number line and put the open circle above 3 and it went towards the right. And then I did the same thing for -3, the open circle, and then it's facing towards the right as well.
Uh-huh.
And then I used the quotient property.
Uh-huh.
And I did log base 4 x squared minus 9 over x plus 3 equals 3. And then that's as far as I got.
Okay. X squared minus 9 over x plus 3 equals 3. So how many people got that far? Did anybody get past that spot? No. Okay, good. So so there's two things, and we will come back and do these on Thursday, all right? But there's two things that you need to think about here. So Mia, when you solved this part of the domain, did you do x squared has to be greater than 9 and then take the square root of both sides?
Yes.
Okay, so This, you may recognize, this is not linear, this is a quadratic. So this is a polynomial inequality. So I have to use the same process that I did before. Remember when in the last section, to find out what the actual domain is. So I can't just move the 9 to the other side and do that. I have to do the method of first find the zeros. X squared minus 9 equals 0. So x squared equals 9. So x equals plus or minus 3. And then I need to make a number line for that with -3 and +3 and test numbers in each spot. Do you follow what I'm saying here? A little bit. Let's just stop, okay? And we'll go over this on Thursday. But I'll say one more thing. This argument here can be greatly simplified. So you think about that. That'll give you something to dream about tonight and tomorrow night. Okay? All right. That's it. Have a little extra break. We'll see you later.
Thank you.
You're welcome.
Thank you.
You're welcome. Slide 11.